Hello everyone, here are the notes for 11.1a. This is the first section of our chapter 11, sequence and series unit. Types of problems we will be seeing. You start a new job that will pay you a penny on the first day and then double your pay every day after. How much will you get paid on the 7th day of work? How much will you get paid on the 14th, the 30th day, and then how much will you make this month? We won't be able to do this whole problem until we've gotten through the chapter, but just to get an idea, for example, first day again, we will get 1 cent. Second day, double that, 2 cents. Third day, 4 cents. Fourth day, 8 cents, and so on and so forth. Now, what these are called is a sequence and or series. Now, a sequence is a list of numbers that changes according to some sort of pattern. When we are thinking about this pattern, we either thinking adding or subtracting or multiplying and dividing. Okay. Now, a general rule, which is what we will be writing, given some type of sequence, will be able to let us know any term throughout that sequence, or if it is a series, it will tell us how much we've earned through a specific number of terms. Now, again, a sequence, a list of values in an order. Again, it will have that same pattern all the way throughout. Okay, for example, if we look at the finite meaning it finishes. Okay, for example, we got 3, 6, 9, 12. That sequence is done. Okay, there's 4 terms through that sequence. The first term is 3, which we will denote as a sub 1. Second term, or a sub 2, is 6. A3 is 9. A4 is that 12. Okay. And again, that subscript number of a 1, 2, 3, 4, that is the position in the sequence. Okay, like A4. Number 12, that is the 4th term in the sequence. Now, for an infinite, if you notice, it has the 3 dots at the end. That tells us that sequence goes on forever. Okay, and again, once you find that pattern, you'll be able to find those terms throughout the whole sequence. Domain of a sequence is always the position of each term, and then the range is the actual terms of the sequence. Now we also have something that's called a series. The only difference between a sequence and a series is that you are taking the sum of those values in the sequence. Okay, if you notice, plus, 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 you are adding up those terms of the sequence. And again, we got finite, infinite. The only difference is those dots at the end. The way we're going to write series eventually is with summation notation. If you notice, we got this little new thing that we have. That is a summation notation. Okay, it's telling us to take the sum of the lower limit, in this case 1, meaning the first term, through the upper limit, in this case 4, through the 4th term. So in that case, we're adding the first term, second term, third term, and 4th term. Now for an infinite, you will see n is equal to 1 through infinity. We will have special formulas that will help us solve for those series. Okay, so our first sequence, 2, 4, 6, 8, 10, and 12. When it comes to finding a rule for a sequence, it's all about finding the pattern. How are we getting to the next term? And that pattern should follow all the way throughout. For in this case, to get to that next term, plus 2. That's how we get to the next term. Now, 2, again, that is our first term. 4 is our second term. So on and so forth. So again, if I was to ask what is the 5th term of this sequence, 5th term, you'd find A5, which would be 10. Now, when it is adding or subtracting, these are called arithmetic sequences. Okay. Now, to help us find the general rule for an arithmetic sequence, you're going to do a sub n, which is representing any term throughout that sequence, equals dn plus a sub 0. D is our common difference, which in this case is that plus 2. So our common difference is 2. Since it's plus 2, it's positive 2. And then a sub 0 is the term before a1. Okay, a1 representing the first term of a sequence, meaning we need to go backwards one term. And if you notice, if we're going plus 2 to get to that next term, then to get to a previous term, we're just going to subtract 2, which in this case will be 0. So just plugging everything in to find the general rule of our sequence above, we got a sub n is equal to dn, which is 2, 2n plus 0, which we're not going to write as plus 0. That's the general rule of that sequence. Now to check, it can be just a quick mental check. Just pick one of the terms, let's say a5. That means you're just going to plug 5 in for n, which is 10, and a5 was 10. Now if I were to give you an infinite series, meaning this sequence, meaning this sequence goes on forever, I could say find the 20th term. Meaning we're just going to take 20 and plug it into our general rule, which would be 40. So just writing some general rules. Again, finding that pattern. Here's our A1, A2, A3, A4, meaning first term, second term, third term, fourth term. And since we have those 3 dots at the end, that means this sequence is infinite, meaning goes on forever. The first thing we need to figure out is that common difference. How am I getting to that next term? Okay, so again, think add or subtract or multiply and divide. In this case, plus 3, plus 3, plus 3. Pattern follows throughout. So in this case, our common difference is 3. And then again, we need to find a sub 0. Again, to help us find the general rule, we're going to use a sub n equals dn plus a0, meaning we need to find that term before our first term, which would be a0, which in this case, to go backwards, we have to subtract 3, meaning negative 2. So just plugging that in, a sub n is equal to 3n minus 2. There is our general rule for that sequence. And again, using that general rule, I could ask you, find the 20th term, just plugging 20 in for n. Now on the next one, you notice it's not adding or subtracting. The pattern to get to the next term, which again should follow all the way through, would be times 3, times 3, times 3. Now, when it was adding and subtracting, we had called it an arithmetic sequence. When it is multiplying or dividing, we are going to think of it as a geometric sequence. What's going to help us find the rule for a geometric sequence is a sub n is equal to a1 times the common ratio to the n minus 1. Okay, common ratio again is just what are we multiplying or dividing by to get to that next term. So in this case, a1 is 4, common ratio, which was times 3, so 3. So our general rule is a sub n is equal to 4 times 3 to the n minus 1, which I'm just plugging those terms in where they should be. Now, when we get fractions, what you're going to do is just break it up into its numerator and denominator. Okay, find the pattern in your numerator, find the pattern in the denominator. So in this case, to get to that next numerator, you're just adding 1. In the denominator, the pattern is plus 3. So both the numerator and denominator are an arithmetic sequence, So you're just basically break it up. Okay, write a rule for your numerator, write a rule for your denominator. Okay, so in the numerator, common difference is 1. A0 would be 0. Okay, in the denominator, A0 would be negative 1. So our numerator, A sub n is equal to dn, so 1n plus 0. In the denominator, we're going to have 3n minus 1. A better way to write this rule, since we don't need to have that 1 in front of n, we're not going to write plus 0, we're just going to have n over 3n minus 1. So I could also give you a general rule, and I'll say write the first 6 terms of the sequence with the general rule of a sub n equals 5 minus n. So find the first 6 terms. We're finding a1, a2, a3, through a6. Find the first 6 terms. So again, all this is a sub n, so when we write a sub 1, all we're doing is replacing n with 1. So this is saying 5 minus 1, 5 minus 2, 5 minus 3, 4, 3, 2, 1, 0, and negative 1. And that's all there is to finding the first 6 terms of a sequence. Use the general rule, plug in your n value. Okay. If you can recognize a pattern in sequence, then we can write a rule for the nth term of the sequence. That's at a sub n. Now, it's not always going to be adding, subtracting, multiplying, dividing. Sometimes we're going to get squares, cubes, fourths. So if you look at the following one, if you notice, they are perfect squares, all of them. 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, 6 squared, 7 squared, and so on. And again, this is A1, A2, A3, A4. So we're taking that n value and we're squaring it. So a sub n is equal to n squared in this case. Later on, we'll get into a little bit tougher ones, and I'll show you how to notice if it's a square or cube. Now, we can also graph sequences. Now, if you notice, so in this case, a sub 1 is 1, a sub 2 is 4, a sub 3 is 9, and so on. All we're going to do, if you remember, the domain is your n values, which in this case is 1, and then the output, or your range, is the actual term. So in this case, if you got the first term as 1, you're just going to plot the point 1, 1. Go to the next one, 2, 4, 3, 9, so on and so forth. So 1, 1, 2, 4, 3, 9, 4, 16, 5, 25. Okay. Now, a lot of you will want to connect the dots. That is not the case. It is just a matter of plotting those points. And if you notice, it's going to look like half of a parabola, which makes sense because n squared, it's a quadratic. Graph of a quadratic is a parabola. That is the notes for 11.1a. There will be an assignment on your OneNote. Make sure to do that, and have a good day.